Okay, so my name's Josh Malina. I work at American Express, and today we'll be talking about time series analysis with Pandas. American Express, as you know, is a company. It employs me. It's a globally integrated payments company. That's the truth. It's a globally integrated payments company. We provide credit cards and other services to enrich people's lives. So don't forget that. So I work in our Sunrise office, which is many miles northwest of here. And I'm on the big data and machine learning team where we work on time series forecasting, anomaly detection, information retrieval, and other NLP stuff. So if you enjoy this talk or you like the idea of being employed or being my colleague, check out this website where you can find opportunities that will enrich your lives. Okay. So just a little more bio. You already know what I work on. I used to live in Virginia, but the most interesting thing on this slide is that I'm a Miami native. Okay? So don't believe the tan or lack of it. I really was born here. Okay? So ask me questions. Okay, so we're going to dive right in. This is only a 30-minute talk. We'll have time for questions. But what we'll be doing in this conversation is talking about time series data and how Pandas can help us pull information out of time series data sets. After this talk, hopefully you'll know about time series decomposition, hypothesis testing, data quality issues, and resampling methods. So with that, we'll move over to the notebook. There we go. So this data set is a publicly available data set. It's car accidents in Seattle, Washington. Any Washingtonians out there? All right. I hope you're not in this data set, sir. Okay, so we're going to be digging through the data set and using Pandas to hopefully extract true information. Right, so this talk is not about forecasting or prediction or neural nets. It's about looking into a data set you've never seen before, a time series data set, and hopefully answering questions with that data. Some of it will be very basic, especially for people who use Pandas a lot or who are very familiar with time series. Some of it might be more interesting to people who have never used some of the time series specific functionality in Pandas. I've been working with time series data for about 9 months now, and so this is sort of an overview of what I've learned in the better part of the year. So at the top of the notebook, we have our imports. A couple of things that I learned while building this notebook is that you can set a default figure size, which is super useful because you don't have to keep telling Pandas or Matplotlib, make my pictures bigger, right? So that's there in this first cell. Here's a few links. When I share the notebook later, you can take a look at the CSV file that we're parsing, a link to the page where it lives, and sort of a data description. This is a very interesting data set. It has a lot of really cool columns. A lot of columns we're not going to use at all, but just to give you a sense of how interesting this data set is, you can see there's like stuff about deer in here and other domestic animals that you might have hit with your car. So feel free after the talk to dig in and let me know what you found. So we'll quickly sort of look at our first Pandas function. This is sort of the mother of all Pandas functions, read CSV. If you look at the documentation for it, you'll be looking at it for a long time. It has lots and lots of arguments that it accepts. Here we're sort of doing a simple function call where we're just passing the path to the data, telling it which columns to parse. If you have a very large data set, you might want to use the second argument here so that you don't read every single column. Pandas also provides a pretty handy-dandy parse dates argument. So if you have a datetime string or something that looks like a datetime string, Pandas under the hood will sort of automatically parse it out and try to make it into a Python datetime object. And by automatically, I mean I don't know how they do it. Okay, humility. Humility is working. I'm going to keep going with that. Index column, the column you want to index on, and then sorting it. And maybe just to step back for a second, a time series data set simply is a data set where the events that occur in it are pegged to a specific time. Right? So it's straightforward, but that's what distinguishes it from other data sets and what makes it interesting. The sort index, so when you call this function, probably the The thing that's going to be the slowest is parse dates, and then maybe sort index afterwards. But it's important to sort it because then you know you're starting at the beginning of the data set. It sorts it in ascending order. So you can see a few of the columns that I'm reading in. Again, we're not going to really use any of them. We're just going to look at vehicular volume in general. But you can see we have columns about severity. We have columns about how many injuries were involved in the accident, fatalities. We also have a couple of fun ones here, like whether or not you hit a parked car in your accident, and whether or not the accident was due to inattention, right? So good for you guys out in Seattle, really collecting a lot of rich data for us. So since we have a time index data frame, we have a lot of really sort of simple ways to get a high-level view of it. And when you're looking at a data set you've never looked at before, you want to lean on these sorts of methods so you can start to develop a feel for the data set. So by looking at the first index value and the last index value, we can see that we begin in 2003 and we end in 2019. And because Python has been able to effectively parse these strings as datetime objects, we can also do datetime arithmetic and see that we have over 5,000 values, or more than 5,000 values over 5,000 days alone. Right, so softball, simple questions. Where does my data begin and end, and how are they distributed? Pandas provides a wrapper around matplotlib, so looking at the data is really easy with a simple call to the hist function, short for histogram. I'm sure none of you knew the end of that word. And here I'm passing in the index to simply get a count of the values. Now, this is a good picture because it doesn't seem like there's big areas of time where we're missing data. It seems like we have data everywhere, so conclusions that we reach with this data set might be reasonable. Another thing you might notice here is that I'm setting this equal to an underscore, so I'm getting rid of whatever the return value of histogram is, and that's good because if I didn't, it would show a cell with all of the array values or a subset of them just before the graph. And I can show you that that's not a pretty thing for a presentation. Right? Who wants to see this? By a show of hands. Who wants to see this? Okay? Not my target audience, okay? So, okay, let's say we have a question. And admittedly, this isn't the sorts of questions that people ask me at AMEX every day, but maybe in your roles, getting insight out of the data and answering questions with a high degree of evidence or believability is important in your role. But I like data and I like storytelling, so I chose to dig into this question. So is Seattle getting safer over time, right? That's a big question. We're really only talking about traffic and accidents. And furthermore, we're really only talking about trend, right? What this data doesn't show is changes in population, changes in transportation options, changes in transportation volume over time. So it's kind of a one-dimensional picture. So the conclusions we reach won't be terribly compelling to like a municipal board or like a government planning agency, but it might be interesting for us as data scientists or machine learning engineers. So time series data is believed to be composed of a few different elements. Just a single point, time series experts believe is made up of 4 or 5 categories depending on how you slice it. One is called level, or the average value. One is trend. One is seasonality. Another one is cyclicality. And the 5th one is noise or error. So time series data sets share with all data sets noise and also probably level. Trend, seasonality, and cyclicality might be specific to time series data. So that's what we're going to focus on. Trend is what it sounds like. Is there a long-term something in the data? Seasonality and cyclicality are a little more interesting. So who knows about these terms? Are these very familiar to you? Yes, right? Seasonality. We know that when they show like unemployment rates, they always deseasonality it. Deseasonality it? Deseason it? Deseasonality, yeah. I think deseason is what you do to like a cast iron pan, so that's not right. Okay, so seasons and cycles. They sound similar, they feel similar in our brains and our mouths, but they're actually kind of different. Seasonality is tightly bound to calendar intervals that you're familiar with. Weeks, months, hours, minutes, years. So something that regularly occurs in the time series data set that you can count on and sort of doesn't vary a lot. Cyclicality is not something you see as often. It's not something that I see as often because I'm not really looking at economic data, but that normally refers to trends that are longer, less predictable, and a lot of times that shows up in like economic downturns, right? So you might have a cycle that sometimes occurs every 7 years, every 10 years, every 3 years, whereas seasonality, it's going to be every Monday, right? Every Sunday, every 5th hour. So that's kind of the difference between seasonality and cyclicality. So if we were able to decompose the time series into these different parts, we could answer this question about safety by showing that there's a downward trend. So graphically speaking, which would be our first tool before trying to decompose the time series, do you guys, I'll ask it twice. So does it seem like Seattle's getting safer over time? Yeses, raise your hand now. Yes? Okay, cool. And no's? Wow. I guess the talk is done. We have a consensus. It's disappointing because I was really looking forward to continuing. But, okay, so yeah, so maybe it is going down, right? So the peaks that we see in like 2006, 2008, we never see peaks that high again, but we do see some pretty high volumes in 2016, 2018. Also, and I kind of said I wasn't going to bring this into it, but I think Seattle's population growth has been growing. So the fact that it's going down a little or staying the same maybe really does lend robustness to the answer, yes, it is getting safer. But let's go through the motions. So there's a few different ways to do seasonal decomposition. If you use a library like stats models, I think that's what I'm using. Yeah, stats models, the way that they detect trend is really just by smoothing out the data. So they take a weighted moving average and they try to get rid of some of the noise so that a data set that looks like this can then later look like this. I would say that the conclusions that you draw in the beginning from that histogram are similar to the ones here, but you might argue that this is like a little bit cleaner. Still, we should sort of couch our answers in the question, how far have we really come? Because in 2004, maybe the average number of accidents in a day are somewhere between 30 and 60, 30 and 70, and by the end of 2018, we're still kind of in that 30, 40, 50 mark. So maybe it is getting slightly safer. That's what makes this question kind of a difficult one to answer with a lot of evidence to really like convince your boss that things are getting better. A lot of times when you're using a forecasting or time series library, they will ask you to tell them whether the time series seasonality is it additive or multiplicative. Stats models asks you this, and also the Facebook Profit Library also asks you this. So what does this mean? What's the difference between additive seasonality and multiplicative seasonality? So the way I like to think of it, I'll show you a graph, and I'll also give you sort of an explanation. So maybe let me show you the picture first. This is a picture of additive seasonality. Well, you can see two things here. One is trend. There's an upward trend. The second is seasonality. It's these regularly repeating seasons, or I was going to say cycles, but we know that's not the right thing to say. But what you don't see is that the seasons do not become more exaggerated as a function of time. They're always sort of the same seasonality-ish. Here, they are becoming more exaggerated, right? So if you had a data set about how often dogs smile like on a weekday, and in the beginning, Mondays are like kind of sad because their owner's leaving, but over time they get more and more sad. Mondays become sort of more Monday-ish. That would be multiplicative seasonality. So I think most data sets you'll find are additive, but you might happen upon a multiplicative one, and by telling these libraries that fact, it will help them decompose it, because when they linearly combine all these features, trend, seasonality, noise, they're either going to add them together or multiply them. So if you can estimate that correctly, or a subject matter expert can give you that kind of insight, it's a good piece of information to hand to the library. So as I've said, stats models is really just smoothing it out. I wasn't completely satisfied with this level of smoothing, so I'm leaning on another method, which I'm excited to talk to you about, resample, to smooth it even further. And I know traditionally in this talk we've waited till the end to have questions, but if any of them pop up, I'm not averse to taking them. I'm kind of old school, out of the box when it comes to question taking. Okay, that one didn't work. So resampling. Resampling is when you change the interval frequency at which you ask the data to give you values. So most of the time what you do is you downsample. And this at first can sound a little counterintuitive because you think like down, that's like lower, that means I'm going to increase the number of values that I'm asking for. So if I started at a day, downsampling might be more frequent. But actually that's false, okay? Downsampling means less frequent. The frequency goes down. So if we started our data set at the level of a day interval, we're going to downsample and ask for them at a month or at a year. Downsampling is really the only thing you can ask Pandas to do and not ask it to invent data, right? So if your data set began at the minute level and then you upsample and ask it for at the second level, Pandas, adorable and friendly as it is going to be sitting there scratching its head wondering like, where am I going to get this data from, right? Does that make sense, right? It's a cool library. It's not a magician, right? It's called Pandas, not David Copperfield. That was impromptu, okay. So, but if you really find yourself in a situation where you do want to upsample, Pandas does provide a few options for filling in the null values that it's going to give you. So there's 3 in particular that I'm going to talk about right here. One is bfill, which stands for backfill. One is ffill for forward fill, and the other one is interpolate. They kind of are what they sound like. Backfill is going to drag the value that you know from the future and shove it back to where you don't know all the values up until the point that you do know. And forward fill is the opposite of that, right? So if I know 10 dogs are smiling on Monday and I know that 20 are smiling on Friday, if I backfill Thursday, Wednesday, Tuesday, I think those are all the days there, are going to have Friday's value, and the opposite of that for forward fill. Interpolate is a little more complicated, but maybe more interesting if there's a linear trend in between your missing values, where Pandas is going to fit a line from the value you know to the value you also know, and then interpolate the values in between there. A note of caution for those of you who are interested in forecasting, you could introduce leakage into your training set if you do this and you make your train test split across this boundary. Because now you've brought in values from your test data set from the future that you wouldn't have otherwise known in your training set. So not like a huge deal, but leakage happens and it's never pretty. Okay, so I've resampled a lot here, right? So our data set started with accidents happening whenever, and then I showed them to you at the daily level, and now I'm showing them to you at the 6-month level. So when you call resample in the Pandas library, it asks for a string. It asks for a string that looks something like what you want. In this case, 6 is the number 6, and M stands for month. Earlier, I did it with day. Over here, 1D. And then after you ask for that, you're just going to get like a group by or an aggregate object that you can't really look at yet. So then you have to tell Pandas what you want to do with it. So you might want to take a sum. So in this case, I'm adding all the accidents that occur in a day. So you can see from the y-axis, that's around 40 or 50 accidents. But if after that I don't ask for sum, I ask for the mean, that's sort of very different. And sometimes that can be kind of confusing. So we started with daily value. Now we're resampling every 6 months, and I'm asking for a mean. What does that mean? What does it mean, right? So we're taking the mean daily value. Notice the y-axis is not changed. If we called sum on it, the y-axis would be much bigger. So now this is much more smoothed out. So maybe I'll ask again by a show of hands. Does it seem like it's getting safer in Seattle? Few people? Less than before, I would say. Maybe you guys are just sort of annoyed and don't want to participate. But yeah, maybe it's not as clear anymore, right? We have many fewer points here, right? So there's a lot less information, but maybe we've gotten rid of all the seasonality and other stuff that might be distracting us. But still, I'm sort of unconvinced, right? And this is my presentation, so. Here's another look at the data. These are box and whisker diagrams across all the years. This is nice for seeing overlap, right? So we see the mean mean values and the whisker tails, there's a lot of overlap here. So it could be the case that it's getting safer over time, but there's still going to be a day in 2019 that looks like a day in 2004, right? They're not like completely linearly separable, right? It would be hard, I think, to build a classifier and to ask it, is this data from the second half of the data set or the first half of the data, right? So ultimately, it's going to be a somewhat unsatisfying answer, but it's kind of a fun adventure, I think, through the data set. So if you're not feeling convinced by visualization or by resampling, you can lean on the dark and now boring arts of statistics before the machine learning stuff came around to do hypothesis testing, right? So one test that's not actually used very often for detecting trend, but is a way of asking your data if portions of the data are generated from different distributions, is this ANOVA test. So ANOVA is a capitalized word, which indicates that it's an acronym, and it stands for analysis of variance. So even though we're trying to detect differences in means, what ANOVA is looking at is the variance across groups compared to the variance within groups. So if we detect a lot of variance across the groups, we could only be secure in our belief that that's caused by differences in the actual groups if the variance in those little clusters or buckets is also tight. Otherwise, we can't reject the null hypothesis, and it could be a fluke. So in this ANOVA test, what I'm doing is I'm separating all the years, and then I'm running it through the ANOVA function to figure out whether the p-value or the f-statistic that it gives me back is going to merit the conclusion that we are looking forward to, whether or not there's a difference. ANOVA asks us to only use it in special circumstances if we abide by a few principles. One, if the samples are independent, which I think is clear, that they're normally distributed, which is mostly true if you look at all these histograms, and that the variances are similar, which you can also see right here. So what did ANOVA tell us? I think it was up here. OK, look, 2 point something something e to the huge, right? So ANOVA is confident that there's some difference here, but it hasn't answered our question, is there a downward trend? It's just telling us there's differences across years. But maybe it gives us a little confidence that we can ask a little deeper. So finally, just sort of being tired of this question, I decided to just chop the data set in half. We have the data from 2003 to 2011, and then from 2011 to 2019, plotted them, ran ANOVA again. ANOVA is still confident. And you can see, and I actually was curious to know what you guys thought of this, because we're looking at two different histograms, right? They're definitely hugely overlapping. And this is a long period of time. But you can see that the second half of the data is slightly to the left of the right. So maybe it is slightly safer. But another data scientist or engineer might look at this and say, actually, there's no difference, right? Look at all that overlap. Anyone have a feeling about this graph or about the conclusion that it is safer over time, accident-wise, in Seattle? OK, great. Yeah, hide behind Slack, whatever you guys want to do. And you can see just how confident ANOVA is with all the zeros it gave us. OK, so that's the hypothesis testing portion of the talk. Now we're going to transition to something else that I thought was pretty interesting in the data set. So when I call df.index and then I look for the first 25 datetime objects, oh, I only have 5 minutes left. OK, I will go through this quickly. So what do we see here? We were expecting datetimes. What do we see? Strings, dates. Where's the time? Where's the time, right? It turns out that in this data set, the police officer, the municipal worker, or whoever was recording these accidents really favored the zeroth minute, right? He arrives on scene at like 12:18, and he writes down in his paperwork that the accident happened at 12, right? This is happening a lot. It's showing me that over 30% of all accidents in Seattle occur during the first 60 seconds of the hour, okay? Do you know what this tells me? It tells me that humans made this data set. What else is overrepresented? The 30 mark, the 10 mark, the 15 mark, right? These human times. So if you were doing a forecasting problem and your boss was asking you, can you predict the next minute? You would probably say no, right? Because this data just has these big problems. This also occurs at the hourly level. right? And I checked. I thought like, oh, maybe all these accidents are happening at midnight, like people are drinking, et cetera, et cetera. No. I Googled it, and Google said that accidents most of the time happen during rush hour. So we can't even predict at the hourly level. But we resample one more time at the daily level, and we're in business. We even see a nice drop on the 31st, because you may not know this. You can look at your knuckles. There's only 7 31sts in a year, right? So nice to see that. A couple of books that I've been reading to help me with this stuff: Practical Time Series Analysis, which you can order on Amazon, and Quantitative Forecasting Methods. Both really good books about forecasting and sort of these nitty-gritty time series analysis stuff. Okay, that's my talk. Thank you very much.
Thanks. Only one question on Slack. Can you use Stas model to build a Garch or eGarch time series model?
I don't know what that is.
All right.
Okay.
Any other questions?
Yeah. To like generate seasonality or to remove it?
To identify patterns and cyclical patterns that are not unclear, we keep it on that time scale. I think something that happens one day. Like that.
I haven't, but that's interesting. Anything else? No? Okay, thank you very much.
One more, actually. I've heard there were advantages to time series indexes in Pandas. Do you know what those are?
Yeah, if you don't index your time series by a datetime object, you can't call resample, right? So it makes your time series data come alive. Okay, we also heard it will fill in missing values if you do that. Thank you.
All right, that seems to be it for Slack.
Okay.
Thanks so much.